Hey guys, this video is week 26 homework answer key video. Okay, so week 26 is trigonometry. Okay, let's quickly go over all the questions. Question number 1. In each triangle below, identify the sides opposite and adjacent to theta. Also identify the hypotenuse. Okay, so opposite side. 1 second, please. Opposite side, adjacent side, and hypotenuse. Okay, so for part A, theta is this angle. Okay, so the opposite side is the one that's further away, which is equal to square root 5. Adjacent side is the one that's next to it, which is 2. Okay, hypotenuse is the longest side of the right triangle, which is 3. Okay, if you use the Pythagorean theorem, you can verify this. Okay, square root of 5 square plus 2 square. This is equal to 5 plus 4, which is 9, which is equal to 3 square. So this is right. Okay. Part B, this is angle theta. Okay, so the opposite side is the one that's further away, which is y. Okay, the adjacent side is the one that's close by, which is x, and the hypotenuse is the longest side, which is z. Part C, this is alpha, this is theta. Let's see what the question asked. Okay, the question is asking us to identify the opposite side and adjacent side to theta. Okay, so the angle alpha here is just to confuse us. Okay, our reference angle is theta. So opposite side is the one that's further away, which is 7. The adjacent side is the one that's next to it, which is P. Okay, so the letter P here means we don't know the number of, like we don't know the value of the hypotenuse. Sorry, we don't know the value of adjacent side. Okay, but we know it's P. And hypotenuse is equal to 10. Okay, so we can actually use the Pythagorean theorem to find P, but the question didn't ask us to find it, right? It just said to identify the side. So I don't think we need to do it, but you can, right? 7 square plus P square is equal to 10 square. So that'll be 100 minus 49, which is 51. So P will be square root of 51, right? This is by Pythagorean theorem. Okay. Question number 2. In each triangle below, find the sine theta, cos theta, and tangent theta. Leave the answers as fractions. Okay, so for this, remember, so, ka, ha. Okay, so sine theta is equal to opposite side over hypotenuse. Cosine theta is equal to adjacent side over hypotenuse, and tangent theta is equal to opposite side over adjacent side. Okay, keep this in mind. So part A, sine theta is equal to, let's identify the hypotenuse, adjacent side and opposite side first. Okay, so this is sine theta. Opposite side is the one that's further away. So opposite side is equal to 5. Adjacent side is equal to 12. And 13 is the hypotenuse. Okay, so sine theta is equal to O over H, which is equal to 5 over 13. Okay, cos theta is equal to A over H, which is equal to 12 over 13. Tangent theta is equal to O over A, which is equal to 5 over 12. It's very easy, very straightforward. Okay, part B. This is theta, right? Again, let's identify the opposite side, adjacent side, and hypotenuse first. This is opposite side because this is the side that's further away from theta, okay? And 9, this is adjacent side, right? This is adjacent side. And 41 is the hypotenuse, okay? So ka twa. Okay, sine theta is equal to O over H, which is equal to 40 over 41. Okay, cos theta is equal to A over H, which is equal to 9 over 41. Okay. Tangent theta is equal to O over A, which is equal to 40 over 9. Okay. That's part B. Part C, okay, this is theta, right? So what is the opposite side? Opposite side. Sorry, I don't know why I said opposite side. Opposite side. This is opposite side, right? Because it's further away. This side is across from the angle, right? And which one is the adjacent side? This is adjacent side, right? Adjacent side is 2, and hypotenuse is 5. So sine theta is equal to O over H, right? So this is equal to 1 over square root of 5. Okay. You can leave the fraction like this, or you can multiply square root of 5 on the numerator and the denominator. So it will become square root of 5 over square root of 5 times square root of 5, which is equal to square root of 5 over 5. Okay, because it's kind of like a tradition that we don't leave the denominator a square root. So whenever there is a square root in the denominator, we always get rid of that. Okay, it's kind of like a tradition in math. Cosine theta, cos theta is equal to A over H. So this is equal to 2 over square root of 5. Okay, so this is equal to, with the same method, 2 times square root of 5 over 5. Okay. Tangent theta is equal to O over A, right? So this is equal to 1 over 2. Okay, so this is 1 over 2. Okay, so that part C. Part D, this is angle theta. Okay, so this is the opposite side, right? And this is adjacent side. Okay, so if you are familiar with right triangles, when you see these two sides are the same, then we know the theta must be 45 degrees, right? This is just like, it's a fun fact, okay? Yeah, so it must be 45 degrees, right? So the tangent theta must be 1. Okay, this is like a special case. Okay, so when theta is equal to 45 degrees, tangent theta is equal to 1, and both sine and cosine theta is equal to square root of 2 over 2, if I remember correctly. Yeah, but we can still like find it based on this graph. Okay. So sine theta is equal to O over H, which is equal to 3 over square root of 18. Okay, so square root of 18 can be written as, okay, so let me write it here. Square root of 18 can be written as 9 times 2 square root, right? So this can be written as the product of square root of 9 times the square root of 2. Okay, so square root of 9 can be written as 3. And this will be the final answer. Okay, so square root of 18 can be written as 3 times square root of 2. Okay, so this is just basic square root properties. Okay, I don't know if you've learned this, but this is good to know. So this is 3 times square root of 2. And 3 gets canceled. It will be 1 over square root of 2. This will be square root of 2 over 2. Okay. Cos theta. Cos theta is equal to A over H. Adjacent side is also equal to 3. So here is also 3 over square root of 18. So all the steps in between is the same. The answer is square root of 2 over 2. Okay. And tangent theta is equal to, let me erase this. Tangent theta is equal to O over A, right? O is equal to 3, A is equal to 3. So the answer is 1. So when theta is 45 degrees, this is like a special case. Okay, so there are a few special cases that we need to remember eventually. 45 degrees, 30 degrees, 60 degrees, 90 degrees, 120 degrees, 180 degrees, 270 degrees, and 360 degrees. Okay, so I will upload like a trig value table. Okay, so we can start memorizing those values. Okay. Let me see. Do I need to go over all the questions? Okay, let's do it. So this is theta, right? And obviously this side is unknown. Okay, so starting from part E, not only do we need to find sine, cosine, and tangent, we also need to use the Pythagorean theorem to find the unknown side first. Okay, so let's do this first. This is theta, then we know this is opposite side, right? And if this is adjacent side, and this is hypotenuse. Okay, so we know that hypotenuse is equal to 4, adjacent side is equal to 1. So what is the opposite side? What is the opposite side for this triangle? It is square root of 4 square minus 1 square. Square root, right? So this is equal to square root of 16 minus 1 is 15. So square root of 15. Okay, so here, this is square root of 15. Okay, so now sine theta is equal to O over H, which is equal to square root of 15 over 4, right? Cos theta is equal to A over H, which is equal to 1 over 4, right? Tangent theta is equal to O over A, which is equal to square root of 15 over 1, which is equal to square root of 15. Okay, that's part E. Part F. So we know hypotenuse is equal to 2. So this is the reference angle, right? So this is the adjacent side, and this is the opposite side. Okay, so again, we need to use the Pythagorean theorem to find the opposite side first. Opposite side is equal to square root of 2 square is 4. 4 minus 1 squared is 3. So 3. So this is equal to square root of 3. Sine theta is equal to O over H, which is equal to square root of 3 over 2. Right? Cos theta is equal to 8 over H, which is equal to 1 over 2. Okay. Tangent theta is equal to O over A, right? which is equal to 2 over 1, which is 2. Ah, sorry, my bad. I read the number wrong. So opposite side is equal to square root of 3 over 1, which is square root of 3. Just give me 1 second. Let me double check this. Yeah, so this is theta is, so here theta is equal to 60 degrees. Okay, theta is equal to 60 degrees. So when theta is 60 degrees, the sine theta is equal to square root of 3 over 2. Cos theta is equal to 1/2, and tangent theta is equal to square root of 3. 3, 2, and this is hypotenuse, right? So this is theta. So 2 is the opposite side, right? 3 is the adjacent side. And we don't know the hypotenuse. So the hypotenuse is equal to, by Pythagorean theorem, 2 squared plus 3 squared. That's 4 plus 9. That's 13, right? So square root of 13. Okay. So sine theta is equal to O over H, which is equal to 2 over square root of 13. Cos theta, A over H, which is equal to 3 over square root of 13. Tangent theta is equal to O over A, which is equal to 2 over 3. Okay, so we did seven questions of the same type. Okay, so starting from part A, so the whole first question is the same type. Okay, so the question 1 has seven small questions, and these 7 questions are of the same type. Okay, so by now we should have, we should be familiar with sine, cosine, and tangent, opposite side, adjacent side, and hypotenuse, and their relations. Okay, so if there's only one thing you need to remember in this section, okay, that's so, ka, and twa. Okay, so ka, twa. Remember that. Okay, so given this triangle, calculate each of the following. So this is 50 degrees, okay? And question says, given this triangle, calculate each of the following. Okay, so when we use 50 degrees, when we use this angle as the reference angle, then opposite side will be 1.532, right? And the adjacent side will be 1.286. And hypotenuse doesn't change, right? It's always 2. Okay, but opposite side and adjacent side depend on which reference angle we use, right? So for the reference angle 50 degrees, the opposite side is equal to 1.532, and the adjacent side is equal to 1.286. So sine 50 is equal to O over H, which is equal to 1.532 over 2. Okay, and cos 50 is equal to A over H, which is equal to 1.286 over 2. And tangent 50 degrees, that's equal to O over A, right? Which is equal to 1.532 over 1.286. Okay, so remember, notice that everything here, all the data here, OHA, all the data here is based on this reference angle, Okay, so I'm going to use a different color when we do alpha. Okay, so part D is asking sine alpha, now sine 50 degrees. So this means starting from part D, our reference angle became this angle. Okay, so so let me write it here. So when the reference angle becomes alpha, angle alpha, the opposite side will become so this is alpha, right? So the opposite side, instead of 1.532, the opposite side will be 1.286 because this side is the one that's across from the reference angle, right? So the opposite side becomes 1.286, and the adjacent side becomes, so this is the reference angle. So 1.532, this side becomes the adjacent side because this side is the one that's next to the angle. So 1.532. So for the reference angle alpha, I'm using the green color. Okay, so for reference angle alpha, this is the opposite side. And this is the adjacent side. Okay, so sine alpha is equal to opposite side over hypotenuse, which is equal to 1.286 over 2. Hypotenuse doesn't change in a right triangle, right? Because hypotenuse is the longest side of the triangle, and that side doesn't change. Cos theta is equal to A over H. So this is equal to, A is equal to 1.532, and hypotenuse is equal to 2, right? So part F says the measure of the angle alpha. So it's asking how many degrees angle alpha is. So this should be, we know that the sum of the three angles in a triangle is 180 degrees, right? So this should be 180 degrees minus 50 minus what's the other angle that's given? It's a right triangle. Is a right triangle. So there's a right angle. So 90 degrees. So that'll be 40 degrees. Okay, so that means the alpha over here, this is equal to 40 degrees. Okay. So that's question 3. Question 4. Find sine 45, cos 45, and tangent 45 using each exercise figure below. Okay. Okay. So sine 45, cos 45, and tangent 45 using each exercise figure below. Okay. So this is 45, right? And this one will be opposite side because this side is across from the reference angle, right? And this one will be adjacent side, right? And we know we can use the Pythagorean theorem to find the hypotenuse. So the hypotenuse will be 1 square plus 1 square under the square root, which is square root of 2. Square root of 2, right? So sine 45, this is equal to O over H, which is equal to 1 over square root of 2, which is equal to 2 over, square root of 2 over 2, right? I think, did I explain why? Okay, I don't remember. So like, okay, so let me explain this again. If you know how to do this, then just skip this part. Okay, so let me explain to you why 1 over square root of 2 is equal to square root of 2 over 2. Okay, so let me erase this. So 1 over square root of 2, we can multiply both the numerator and the denominator by square root of 2. So this will become 1 over square root of 2 over square root of 2 times square root of 2. Okay. So the numerator will become square root of 2, and the denominator will become square root of 2 times square root of 2. That's square root of 2 squared. So that'll be 2. Okay. It's a very easy operation. Okay. It's a very easy operation. Okay, so that's sine 45 degrees. Cos 45 degrees, that's A over H, right? A over H. Adjacent side is also equal to 1. So the number here is the same, square root of 2 over 2. Tangent 45 degrees is equal to O over A. So that's 1 over 1, which is equal to 1. Okay, so that's the first graph. Now let's look at the second graph where the two sides of the triangle is both equal. The two sides of the triangle are both equal to 1.25. So we can use the Pythagorean theorem to find 1.25 squared times 2 and square root. So that will be, so I'm using calculator now. Okay, so the hypotenuse will be 5 times square root of 2 over 4. Okay, so 1.25. So this is equal to 5 over 4. This is equal to 5 over 4. Okay, I think using fractions might be a little bit easier for us to do all the simplification and factoring. Okay, so if the reference angle is 45 degrees, then just give me 1 second, please. So if the reference angle is 45 degrees, then this side is the opposite side, right? This side is the opposite side. And this side is the adjacent side. And this is hypotenuse, right? So sine 45 degrees is equal to O over H. So here we are going to use these numbers, okay? So O over H is equal to 5 over 4 over H is equal to 5 times square root of 2 over 4. So this is equal to 5 over 4 times 4 over 5 times square root of 2. Okay, so again, because I don't know how much you know about like the division of fractions, okay, but this is a very common, this is a very basic operation. I hope you know it. Okay, if you don't know how to do this, please let me know. Okay, so 4 gets canceled out. 5 gets cancelled out. So this would be 1 over square root of 2. And this will be square root of 2 over 2. Okay, so notice this number and this number are equal. Okay, which means even if the triangle got bigger, as long as the angle is the same, 45 degrees, sine 45 degrees is the same. So let me try to rephrase this. So sine 45 degrees is the same regardless of the size of the triangle. Okay, so I'm not going to do all the calculation because it takes too much time. But let me tell you, cos 45 is also equal to square root of 2 over 2. Tangent 45 is still equal to 1 in the second triangle, which is bigger than the first one. Okay, and if you do the same operation, we can see in the third triangle, this triangle is even bigger, right? The sides are 2, 2. And if we use the Pythagorean theorem, we'll find the hypotenuse is equal to 2 times square root of 2. But even that, sine 45 degrees is still equal to square root of 2 over 2. Cos 45 is still equal to square root of 2 over 2. Tangent 45 is still equal to 1. Okay, so this question, again, this question is too much work for such a simple conclusion. Okay, I don't like this question. What fact do they demonstrate? This fact is, if we're given an angle theta, okay, then sine theta, cos theta, and tangent theta are always the same, regardless of the size of the triangle. Okay, so what does that mean? That means, for example, let me draw an angle. Okay, so let me tell you this angle is theta. Okay, and now let me copy this and let me paste this. Okay, actually, let me. Okay, so okay. So let me copy this triangle. Okay. And I copy the angle and I made the angle a lot bigger, right? I made the angle a lot bigger. But because the angle is still equal to theta, sine theta, cos theta, and tangent theta of these two theta are the same. Okay, so all the trig functions don't change as the size of the triangle changes, as long as the angle stays the same. Okay, so that's the simple fact the question was trying to tell us. Okay, So that's question 4. Question 5, there's nothing to explain, right? You just use a calculator to find the following ratios. For example, sine 40 degrees, that's close to 0.6428. Oh, it says round to 3 decimals. 3 decimals, that'll be 0.643. Okay, and cos 3, that's 0.00, sorry, 0.999, etc. Okay, so I'll leave this to you because as long as you know how to use a calculator to find the ratio, there's nothing to explain. Okay. So in the given triangle, find the values of the following in terms A, B, and C. This question looks a little bit hard, so let's try to do this together. So sine theta. So for part A, this is theta, right? So this is theta. Then the opposite side is this one. So A is equal to the opposite side, right? And B is the adjacent side. And C is the hypotenuse, right? So sine theta, this is equal to O over H, which is equal to A over C. Okay. Cos 90 degrees minus theta. So, okay, so here our reference angle has become this angle rather than the angle theta. Okay, we know this angle is 90 degrees, right? So the sum of these two angles must be 90 degrees as well, right? So if this angle is theta, then this angle must be equal to 90 degrees minus theta. Okay? So let me use green color for 90 degrees minus theta. So if this is the reference angle, then B will be the opposite side, right? And A will be the adjacent side for 90 degrees minus theta. So cosine 90 degrees minus theta, this is A over H, but the green color. Okay, this is equal to A is equal to A, H is equal to C. Okay, cos theta. So we're back to red color because this reference angle is theta. So cos theta, we know this is equal to A over H, but red color. So this is equal to A is equal to B, H is equal to C. So B over C. Sine 90 degrees minus theta. Back to green color. Okay, so this is O over H. O is equal to B, and H is equal to C. So B over C. Tangent theta. Tangent theta. Okay. Tangent theta is equal to O over A in red color. So this is A over B. And tangent 90 degrees minus theta. This is green color. So this is also O over A. But this is B over A. Okay, so this question, let me mark this. It's worth doing again. Okay, this question is worth doing again. So question 7, in each of the following figures, find the value of the unknowns. Correct your answers to 2 decimal places if necessary. Okay, so this angle is 37 degrees, right? And because this angle is 37 degrees, and this is our reference angle, this is the opposite side, right? And this is the adjacent side. Okay, so if we use, and this is hypotenuse, right? If we use sine 37 degrees, we know this is equal to O over H, which is equal to Y over 5. Okay, so this means if we know what sine 37 degrees is equal to, we can find Y. So here, we just use calculator. Use calculator. Okay. Sine 37 degrees is equal to sine 37 is equal to 0.6018. This is equal to Y over 5. So Y is equal to 5 times 0.6018, which is equal to 3.01. Okay, so this is how we find the opposite side. Okay, what about the adjacent side? If we use cosine 37 degrees is equal to A over H, which is equal to X over 5. This means if we know what cosine 37 degrees is equal to, then we can find X. Again, use calculators. Okay, so cos 37 degrees is equal to 0.7986. This is equal to X over 5. So this gives us X is equal to 5 times 0.7986, which is equal to 3.99. Okay, so here, these two are our answers. Okay, X is equal to 3.99 and Y is equal to 3.01. So basically this question, we solved this question by using sine and cosine. Okay, if we want, we can use tangent too, but in this particular question, both adjacent side and opposite side are unknown. So there's no point of using tangent because tangent is the ratio of opposite side and adjacent side. Okay, so here, that's part A. Part B. Okay, so this question is full of this type of questions. Part B. So we know this is the reference angle, right? So X is the adjacent side, right? And this is opposite side. And the hypotenuse is also unknown, right? So here, what should we use? We should use tangent, right? Because tangent 30 degrees is equal to O over A, right? So if we use tangent 30 degrees, we know tangent is equal to O over A, right? So in this case, it's equal to 8 over X, right? So this means if we know the number, if we know the value of tangent 30 degrees, we can find X. So here we use calculators. Okay. Tangent 30 degrees is equal to square root of 3 over 3 is equal to 8 over X. So this gives us X is equal to 8 times 3 over square root of 3. Okay, and this is equal to 24 over square root of 3. So this is equal to 388 times square root of 3. Right? I think so. Okay, so let me double check. Yeah, 8 times square root of 3. Okay, so that's X. So now we know X is equal to a times square root of 3, we can either use the Pythagorean theorem to find hypotenuse, or we can use cosine, right? Or we can even use sine, doesn't really matter. So now we have a lot of choices. Let's just use cosine. Let's use cosine. So cosine 30 degrees, we know cosine 30 degrees is equal to A over H, right? And we know A is equal to A times square root of 3 over H is equal to Y, right? So this means if we know the value of cos 30 degrees, we can find Y. So what's cosine 30 degrees? Is square root of 3 over 2. So square root of 3 over 2 is equal to 8 times 8 times root of 3 over Y. Okay? So here, it gives us Y is equal to 8 times square root of 3 times 2 over square root of 3. Right? So this square root of 3 cancelled out, it will be 2 times 8, which is 16. So Y is equal to 16. So here we found X is equal to 8 times square root of 3 and Y is equal to 16. Okay, so how do we know? Like I did the steps pretty fast, so I'm not even sure if my calculation was 100% correct. Okay, I hope they're correct. But if I'm not sure, how can I verify this? I can simply use the Pythagorean theorem, right? So so here is the verification. Okay, so verification. If I want to verify whether my calculation is correct, I can simply use the Pythagorean theorem. Okay. So by Pythagorean theorem, we know that 8 squared plus a times square root of 3 squared should be 16 squared, right? So 8 squared, that's 64, right? 8 times square root of 3 squared, that's 64 times 3, which is 192, right? So 16 squared, that's 256. So 64 plus 192, it is 256. So that means my calculation is correct. Okay, so this step is by the Pythagorean theorem. Okay. I don't think I need to do the rest of the 3 small questions, because I think if you understand the first 2 questions, then for the last 3 questions, it shouldn't be a problem for you. Okay, so if you don't know how to do them, just watch the steps in the first 2 questions again and try to copy my steps. Okay. So I guess that's everything for this week's homework. Let me see if there's anything else I want to mention. No, I think I've explained everything I wanted to. Okay, so this will be the week 26 homework answer the key video. Okay, hopefully this can help you understand the materials better. Okay, guys, I will see you on Saturday in class.